back to geometry. Before we go any further, I just want to take a little time and talk about bi-conditional statements, if and then statements. You have these in science, so I don't think it's like new to you, but let's just take a look at it. When I talk about a conditional statement, that means there is a condition. So an unconditional love, there is no condition, but conditional means if, then so and so and so. So a conditional statement has an if part, which we call the hypothesis, and then it has a then part, which is called the conclusion. And in geometry, this comes into play a lot when we're looking for a given or we're trying to prove something. So the hypothesis is given to us. That is really our given. And the conclusion, this is what we're trying to prove. This is what we want to prove. The only real proof that we have done so far was if two angles are vertical, then they are congruent. And we shortened it to say vertical angles are congruent. So sometimes you have to kind of pick out the if and the then, and sometimes it's very, very obvious. But every time, in every conditional statement, there will be a given or an if part, and there will be a prove or a then part. I want to look at what happens if we switch those parts around. So I'll take a statement that's really not about geometry. Let's take this. Let's say if you live in Florida, then you live south of Canada. Because we know Florida is at the southernmost part of the United States on the East Coast, and we know that Canada is the north of the United States. So let's see if we think this is true. If you live in Florida, that's the condition. If you live in Florida, then you live south of Canada. And that's our conclusion, and that's absolutely true. That's true. Now let's switch the if and the then part around. When you do that, when you switch the if and the then part, you've created a statement that is called the converse. So the converse of that statement would be, it's just like the shoe. I mean, maybe you don't know it, but there's a brand of tennis shoe called Converse. It always makes me think of that. But in geometry, it's just switching your if and your then. Switch them. Sometimes it'll still be true, and sometimes it won't. So let's look at this one. Let's change it around, the if part. Let's say if, and I'm going to abbreviate, you live south of Canada, then you live in Florida. Now, think about that just a minute. I definitely switched them, right? I have created the converse. That is the converse. It's still a conditional statement. It has an if, which is my hypothesis, and it has a then, which is my conclusion. And it says if you live south of Canada, okay, then you live in Florida. Well, is that true? No, not necessarily. Because if you live south of Canada, you could live in any of the states between Florida and Canada. Lots of places you could live south of Canada and not live in Florida. So that's not true. Okay? Sometimes the converse will be true. Sometimes the converse is not true. Let's think of a reason that this is not true. If you live south of Canada, you live in Florida, let's say that you live in South Carolina. Okay, let's say that you live in South Carolina. Well, South Carolina is definitely south of Canada, but it is not in Florida. So this would be an exception. This would be something that would prove that statement is incorrect. So we call that a counterexample. Counterexample. And a counterexample is just a statement that proves another statement to be wrong. That's all it is. It just proves something to be wrong. Okay? So what we've proven here really is that if we have a converse, it might not be true. It might be true, but it might not be true. All right, let's take another one. Let's take the word inverse. Inverse. Now what the inverse does is it takes the same statement that we started with and it just makes them both negative. And sometimes it's going to be true and sometimes it's not. So let's make them both negative and see how that sounds. Okay, so go back to your original. If you don't, see that's your negative. If you don't or do not live in Florida, then you make them both negative, then you don't or do not live south of Canada. Well, that is the inverse. We have correctly formed an inverse statement. We just made them both negative. So let's see if it's true. I'm telling you that sometimes it's true and sometimes it's not. So let's see if this one is. This one says the condition, the hypothesis. If you don't live in Florida, I don't live in Florida. If you don't live in Florida, then you don't live south of Canada. Is that true? No, I don't live in Florida, but I do live south of Canada. Let's say that someone lives in Colorado. If you live in Colorado, you don't live in Florida, so you live in Colorado, say, then you don't live south of Canada? Wrong. Another counter example. Sometimes when you make both of the statements negative, it will be true, but not always. Now here's the biggest word of all. This is called contrapositive. Say it with me. Contrapositive. Contrapositive. Okay? So I'm going to write that one down. Contrapositive. Okay, to get your contrapositive, you're going to switch your if into then, and you're going to make both of them negative. Yeah, you can do both of those. Switch them and make both of them negative. And you know what? It will always turn out to be a true statement. So let's look at it and see on this one. Okay, we're going to switch them. So our original was if you live in Florida, then you live south of Canada. So I'm going to switch it and I'm going to say if you, now you switch it and make it negative. So if you don't live south of Canada, if you don't live south of Canada, then, okay, now we've got to make the first one negative. You know, we switched to make them both negative. Then you don't or do not live in Florida. And sometimes these can feel like brain teasers or something. You may have to read it a few times. Let's read this one over again and see if we agree that it is true. Okay, if you don't live south of Canada. Well, if you don't live south of Canada, you must live north of Canada. So if you don't live south of Canada, you surely don't live in Florida, do you? Say that again. If you don't live south of Canada, I mean Florida is south of Canada, way south. So if you don't live south of Canada, then you don't live in Florida. You do not live in Florida. And so that is true. So what we've come up with, and I've given you a lot of these to practice on a downloadable sheet because you just need to practice a lot of the different statements to get the feel of it. But here's the truth. Your converse, which again you get by switching your if and your then. You just switch them, and you have to work on this to remember. You just switch them. You may or may not get a true statement. So the converse may or may not be true. So let's say that the converse is sometimes true. Sometimes true. Not always. Okay? And let's take your inverse. And your inverse was when you didn't switch anything, but you made them both negative. Made them both negative. And we got something that wasn't true, but sometimes it will be. So your inverse is the same thing. Sometimes it's going to give you truth, and sometimes not. So let's say that our converse is also sometimes true. Sometimes true. But the good news is there's one we can count on to always be true, and that is the contrapositive. If we switch them and negate them, which means make them both negative, it will always be true. It might be a long sentence to say, but it will always be true. And you may have to read it a few times to get it that it's true, but it will be. So your contrapositive is always true. Always true. So what we're really saying is that if your conditional is true, I mean, we've got to be given that our original statement is true. If our original statement is true, then the contrapositive will always be true also. If our original statement is true, then our converse, which we get by switching, might be true, but it might not be true. And our inverse, which we get by negating, changing both to negative, it might be true, but it might not be true. But if we change places, switch them, and we negate both of them, make them both negative, it will always be true. So I want you to know this terminology. You will have it in your schools, in your classrooms at school. You will have it in your text if you're homeschooling. You could have it on your SAT or on your GRE or any test that you might be reviewing for, whatever your circumstance is. These words and terms can pop up anywhere. So our original is our conditional statement, if and then being a hypothesis and conclusion. And given that that is true, then converse might be, inverse might be, contrapositive will be. Something else I want to put into this section is sometimes you will see this written in a book, IFF. And what that means is if and only if. Let's just say that that means if and only if. It's just a shortcut. It's an abbreviation. Math is full of them. It's abbreviation for not having to write out if and only if. So we kind of understand what if and only if means just in real life, you know. If I will go to the movies if and only if it is raining outside. I know what that means. It means if it's raining, I'm going to the movies, and that's the only condition I'm going, if and only if it is raining. So we understand if and only if. But in mathematical terms, what if and only if means is that I can switch and form the converse, and it will always also be true. So if it says if and only if, it's just another way of saying that it means the converse. You know, for that particular statement, the converse is true. The converse is not always true, but if it uses the word if and only if, the words if and only if in a statement, that's just a way of telling you can read it frontwards or backwards, and that's the converse, and that you will have a true statement. So it pops up a lot, not that much, but I want you to know what it means. If and only if IFF means the converse will be true if you see the word or the words if and only if. So that is kind of what you need to know as far as just the basics that you will see a lot as we move a little more into proofs and other problems that we work when we get a little more into problem solving. So this is kind of something you got to work with a little bit and commit to memory. You know, you just have to make some flashcards or something and really practice until you get how those are formed. They're in your textbook, any geometry textbook that you may be using. You will find these, and you will find a nice explanation and many examples for you. So practice it until you have it down pat. And when we work with them, it will be a piece of cake. See you later.